Alrighty, everyone. Sorry, just getting this set up to my Google Meet session. Okay, here we go. All right, so this is what we did in the Google Meet session on Monday and Tuesday if you were not available to come. So we are going to do a whole bunch of different kinds of probability questions, all the different types of questions that are on your test on Wednesday. So to begin, let's see, we'll do the basic dice chart probabilities first. So refer to the rolling 2 dice chart. Calculate the following probabilities. So sum of 8, if you look on your chart, is 5 out of 36 plus 6 out of 36 is your doubles. So 8 or doubles. And then if you think about it, you have to think, okay, every time I do an addition, is there anything to subtract? And sum of 8 has a 4-4 double in it. So you counted that twice, so you have to subtract that out. Then you just simplify your fraction, get 5 out of 18. Okay. A sum of 7. A sum of 7 has 6 out of 36. A sum of 11 has 2 out of 36. If you're looking at your dice chart, you get 8 out of 36, and those are mutually exclusive. There's no way that you can roll a sum of 7 and a sum of 11 at one time. All right, playing blackjack. Here we go. You're dealt a card from the top of the shuffle deck. So we're only pulling one, so it's a heart or spade. There is 13 hearts plus 13 spades. There is no way to get a heart spade card, so there's no overlap. They have nothing in common, so it's 26 out of 52, which is just basically half the deck. Okay, a heart or an ace. Here we go. There are 13 hearts plus 4 aces. Is there a card that's both a heart and an ace? Yes. 1, 16 out of 52, and then you can simplify. If you want to simplify on your calculator, you type in 16 divided by 52, and then hit the math frac button, and it'll simplify for you. But all questions on the test will be turned into decimals anyway. All righty. An advertising firm reports that a certain advertisement on radio and TV is heard by 30%. We're going to make a Venn diagram. And is viewed by 20% on TV, only 5% is both. So this is not mutually exclusive because we have a both. And I'm just going to turn these into percentages. This would be 5 in the center. And then because that's our both, and one is TV and one is radio. All right, so 30% on radio. So this total circle is radio. Total circle is 30%. So that would be 25. Okay, because the total is 30, so you already had 5 in there, so 25. Then over here on TV, you already have 5 inside the TV circle, so we would do 15 because the total is 20. Always do an Venn diagram, the center first. All right, so what's the probability that it's seen on TV? The total TV is 20. And then I forgot to do something. Okay, we'll see. We'll do it in 1 second. Okay, seen on TV and heard on the radio. So you have to be in both. So that's our both right there, 5%. And then the next one says neither seen on TV or heard on the radio. So that means you didn't hear it on TV or the radio. So that's outside of here. So inside of here is 30 plus 15 is 45. So that means they didn't see it on TV or the radio. That's neither. That's 55%. Inside was 45, outside was 55. And then E, either or. So you just add up all of these. I either saw it here or both. That's our 45, excuse me. All right, now the given. Seen on TV, given that they did not see it on the radio. Okay, so they didn't see it on the radio. So anything in radio is not given. So I'm going to cross that out. So not radio. Given they didn't see it on the radio. So I cross out the radio. And now my total is going to be 10, 5, 6, 70. So it's out of 70. That's my new denominator. And I saw it on TV. So 15 out of 70. And then you can divide. Okay, so the given was not radio. So you scratch out all of your radios. Next one, table ones. All right, if a person Okay, if a person is selected at random, what is the likelihood that he or she will be victimized by a stranger, given that a robbery victim was selected? Okay, so that's our given. So our given is this. That's all we're looking at. It's our given. And then they were victimized by a stranger. So 379 out of 505. And then you just divide. Given that an assault victim is selected, so we're given an assault victim. So next one would be, let me erase that one. Okay, so now we're given an assault victim. That's all we're given. What is the likelihood that that criminal is a stranger? So it would be 727 over 1426. Your denominators are always the total unless you're doing a given problem. Find the probability that when one of the strangers is randomly selected, the person chosen was victimized by an acquaintance or relative. Okay, so now we're looking at this as our given. They were victimized by an acquaintance, given that he or she was robbed. Oops, I did it backwards. Sorry. Wait, hold on a minute. Sorry. Given that he or she was robbed. So we're only looking at the robberies, 505, and acquaintance given robbery, 106. Sorry, I read that backwards first. All right, next one. Find the probability that when one of the subjects is randomly selected, the person chosen was robbed by an acquaintance or a relative. Acquaintance or a relative. So you go out of, it's not a given, so you're going to do out of the 2,000 because they're not giving you anything. It's the whole chart. And then you want to know acquaintance relative. So the total acquaintance relative is, person was robbed by an acquaintance or relative right here, 106. There we go. They were robbed by acquaintance and a relative. So the 106 people were robbed by an acquaintance or a relative. Find the probability of getting somebody who was victimized by someone unknown to them or who was a homicide victim. Okay, so this is an or, so we're going to be adding. Let me erase. Okay, so let me read it again. They were victimized by someone unknown to them, or, that tells me I'm going to add, or they were a homicide victim. Okay, so unknown would be 95, or homicide. So that would be 95 plus 69, and then you see where you counted this twice, minus 18. So 95 plus 69. Unknown is 95, homicide is 69, minus 18, and that's all over 2,000. And I think after you simplify everything, you get like 073. You're good to go on that one. All right, you're going to draw 3 cards from a deck of cards and not replace. So make sure you know the deck of cards. Here we go. Find the probability that all 3 are 7s. We're not replacing. So we're going to pull the first card and then the second and then the third. You hear the and? That tells me I'm going to multiply. First and then and then. So first pull, there are 4 7s in a deck out of 52. Now, you're not replacing, so there's only 51 cards left, and you're pulling out 3 7s in a row. So 3, 50, pulling out 3 7s in a row. You already pulled 1, 2, so there's only 2 left. Change these to decimals, multiply them together. Okay? All right, find the probability of at least 1 king. All right, these at least 1 ones. All right, hardest ones in the chapter. So at least 1 king. Oops. We're going to do it with replacing and then not replacing. We're going to do it both ways. Okay, so it doesn't matter for the replacing and not replacing. First of all, if we do at least 1 king, either way you do it, you're going to do 1 minus, and you always do the opposite. So we're going to do no kings. All right, there are 4 kings in the deck, so there would be 48 of those. All right, so let me slide down a little bit. And I'm going to do replace first. And then I'm going to do not replace over here, so you can see the difference. All right, so at least 1 king. 1 minus no kings, opposite and side. And how many cards did I pull? 3 cards. So it would be that to the 3rd. That's your answer for that. You just type it in. Now, not replacing. 1 minus no king again. 1 minus no king. The first no king is 48 out of 52. The second no king is 47 out of 51. And then the third no king is 46 out of 50. And then you just do your decimal. So the at least ones are usually the 2 of the types that are the hardest to do, or the at least ones. All right, last question. Here we go. We have 3 branches of a local bank that have that many clients per day. 1, 2, 3. And I think that adds up to 400. So this is branch 1, branch 2, branch 3. So the probability of somebody going to branch 1 is 120 out of, that's 300, and another 100, so out of 400. Branch 2 would be 180 out of 400. Branch 3, branch 3 is 100 out of 400. All right, suppose the probabilities that a client will transact business involving more than 100 each day are 0.5, 0.6, and 0.7. All right, so this means this is over $100 in transactions. So under $100 would be 0.5. These all have to, remember, each of your branches have to add up to 100%. So if this is over $100, then less than $100 would be 0.4. Over $100 would be 0.7. Under 100 would be 0.3. And there's your tree diagram. We should probably change these to decimals. So that's 0.25. And then 12 divided by 40 would be 0.3. And then your last one would be 0.45. All right, so there's all the probabilities that we need. All right, first question. What is the probability that the client will transact business over 100? So over 100, I can go to branch 1 and do it. Go to branch 2 and do my transaction, or I can go to branch 3 and do my transaction. So if I went to branch 1, that's going to be 0.3 times 0.5. Went to branch 1 and I did the transaction over 100. Branch 2 and I did the transaction over 100. 3 and I did the transaction over 100. So the probability of me doing a transaction over 100 is that plus that plus that. So you would get 0.15 plus that's 0.27 plus 0.175. So let's add those up. We get 0.15 plus 0.27 plus 0.175, and we get 595. So we add those up. We get 595. All right. What is the probability that the client went to the first branch given that it involved over 100? Okay, so now the question is probability that they went to branch 1 given that it was over 100. Okay, so that means that's all you're looking at now. That's all you're given. So your givens are just these branches. And those 3 branches totaled up to 595. That's what you're given. Since that's what you're given, you don't look at these other branches anymore, just the 3 yellows that I'm going through. And it said, what is the probability they came from branch 1? Don't ever take a partial branch. The probability that they came from branch 1 going through here is 0.15. Just divide those 2, and you get 252. And that's it. There's your probability review.